Student, today we start with chapter 6, linear perspective drawing. This is a long chapter and I think that is one of the important chapter for this course, so try to read many times, repeat before you do the homework assignment. First of all, we need to know few of vocabulary, for example, stencil, station point, picture plane, lines of sight, horizontal line. This is some of the basic definition, so you can learn. You need to know before you start with drawing. Station point is the point where you stay to look at the objects on the view, so that's why sometimes it locates depend on you stand up and your eyes to look at the objects. They call that the standard point. The second one is picture plane. That is some of the plane you look hold up the objects in the window. For example, you look the object very far from you and everything, you focus on one of the plane, and they call that the picture plane. They show all of them on there. The lines of the size is the sum of imaginary center axis line projects from the object, the people eyes. That is the station point, and after that they intersect the vertical picture plane perpendicularly. It's a perpendicular to the objects. After that we have horizontal line. That's in the line from your eyes view. Horizontal line represent the observer eyes level, and it is records on the picture plane. So on a definition, you can see that's on the picture. Round line is the line where the picture plane and the round meet together. The round line lines within the roof plane from which vertical measurement are made. That's one you measure the real height from the building. Round plane is the reference for the plane where the observer is situated. It can be at any level. You can select any level and depend on the vantage point from the perspective view. If you have 3-point perspective, have only perspective line, then you call that's the round line. Vertical measurement line is the line vertical, the first one, and the second one with the picture plane. Vertical height dimension are transferred from elevation to this vertical true line, and in the order to be projected into the perspective drawing. So this is the one you measure the height from the object you working on. Next one is the midpoint. The point is located on horizontal line, and it lies in halfway between the vanishing point in 2-point perspective. When you draw 2-point perspective, you select 1 point in the center where you can see both sides, and you call that the midpoint. Horizontal measuring line. Before you have vertical, and horizontal is the one you measure the width from the objects. You call that horizontal line. Perspective is the methods of depicting the manner from which objects appear on the human eyes. When you see that, and you can transfer that on the picture, and you call that perspective. This is their relative position and the distance. Architects, they use perspective in both preliminary and the final design stage. That means when they start with the projects, they use for perspective to draw, and after that at the final stage of design they go back again with perspective, and they utilize both drafting traditional manner, manual method, and after that computer program. Combine both of them when they do for perspective view to add in the design process. This is one of the picture show you on of the definition I talked with you when we beginning. So you look at this. This is the objects. You see that this is the objects, And when you stay here, it's called at the center point, where you stay to look at the objects. And when you look at the object, even the objects, it have 3D. They have the height, the depth, and the width. But when you look at all of them, you look on one of the plane. You look at this one, you see they call that the picture plane. This is the picture plane. And when you see the projects, it's on here. It show everything on here, and you call that the picture plane. And when you stay here, you look through the projects on the picture plane, you see everything on the picture plane. And the view, the light view, when you look on the projects at on of the points from the projects or the object, and you call that the line, the line from you can, the ray, they call that the ray line, the one you stay here to look, to view the projects through the picture plane. So that's the station point. The station SP stands for station point, where you stay to look or you view the projects. Okay, so in the preliminary design stage, you usually use the freehand perspective drawing. Is fast, it can transfer the idea very quick. And after that, during the early conceptualization stage of the design, when you go back everything and you study model, that's mean later step from you do from in design. In the final presentation stage, some kind you use perspective again to do for accurately the construction for the purpose for rendering them. This is some more definition. When you draw for perspective, you need to learn from they call that's the object. That means the one you need to look at this and you draw, you transfer in the paper plane. That's a behind for the picture plane, like you see before. The picture plane and the objects in behind of that. With the picture plane right here, and the object is behind from this one. And after that, we have vanishing points. When you do the object and you do for picture plane, you look at that and you need to go for both sides. From the object before you draw, you have the vanishing point. And the definition they have the when the object does not touch with the picture plane, and always construct or trace the plane view and note on of the planar element and their angle related to the picture plane, and you call that vanishing point. You draw the line construction lines very light, because when you do construction light, that's the basic when you draw the object or the project. So that's why you need to do construction line very light, and later with the main line from the projects or the objects you need to darker. Well, that's one. And the construction line is parallel to all of the planar elements, regardless for the whether they are on the left or the right side from the building. Drop these perspective line. That means you go vertical from the picture plane to the horizontal plane, and you call that the projective line. Projective line is relative to the station point on the left element to go to the left vanishing point, and the all right side planar element go to the right. You call that vanishing point. Vanishing point is the left right from the eye level, the projects. So now this one is show you about that definition. For example, this is the objects. You see that they say number one, that's mean the object. This is you look from the bird eyes view. That means on the top you look down, and the project look like this. And the plane right here, the plane transfer everything for you can see the projects. They call that the picture plane, like you know before. When you stay here, they call that the standard point. SP stand for standard point. When you stay here to look at the project, you see this side. You also see this side. So that's why you see both of them. So you need to draw both sides. And that's one you call that the 2-point perspective. So now, if you see the projects like that and standard point right here, you create a line parallel with one line from the object on this side. And when this line cut with the picture plane, This is you call that vanishing point right, because it's on the right side. Now you drop vertical down to the round line. This is the round line where you can stand right here, and you call that the round line. Horizontal line is the line from the eye view. That means you can see by your eyes over there. You call that the horizontal line. When you drop down the line from vanishing point down to the horizontal line and the round line, and this one you transfer to horizontal line and vanishing point line. You drop right here, and this one you call that the vanishing point right. Start right here, cut right here. And you do the same thing on the left side. From standard point, you draw the line parallel to one of the line from the objects, this here. And after that, with the line cut with the picture plane, you drop vertical down to the round line and horizontal line. You call this one a vanishing point. Vanishing point left is on the left, vanishing point right in the right. And when you see the projects touch or reach with the picture plane, and this point you drop down vertical to the round plane. This one they call that's measuring line. That means the line you measure the height, the real height from the building. So if they set the building high like this, and you go straight like this and stop right here, that's the highlight from the building, the real height from the building. From this one you connect with vanishing point right and vanishing point left, and you can see this is the space right here. They call that perspective on the left and on the right. So you have two perspectives before you draw the building. So you can see both sides like this. From here you stop like this. From here you connect with vanishing point and stop right here with the straight drop down vertical. And this line we call that the view line. That means the view line, you will see the building inside here. Okay, now continue with that. We have a couple more. Like before, you say vertical measuring line. That means the line in the projects right here, the one from the object. They cut or they touch with the picture plane. You drop down this one to the round line, and this line you call that measuring. So you call that the measuring line. Vertical measuring lines, VML, that touch with the picture plane to the project's contraction line into the volume and the fronts of the picture plane. That's the definition. So now the picture plane, usually they have three-dimensional objects. When we see it's inside there, so you can see everything on the picture plane. These images are translated onto the two-dimension plane because the object itself has 3 dimension. After that, it transferred to the picture plane is 2D. That means everything you see on the picture plane. And that's one you call that the picture plane. The station point is the one like before I told you, that's the observer or observer head, where you can look at the objects. The picture plane is always perpendicular to the drawing surface. When you have the surface on the floor, and the picture plane is vertical with that one. So now, for example, when you stay inside from the office and you look outside, you see the height from the building outside, and you can see every building outside, but you look through the window, and the window right here it can explain for you that this is the picture plane. You see everything from the window right here. The building outside, you can see that it has 3D, but everything you see right here on the window, it is 2D. So that's why you call it the picture plane. Same thing with this one. When you see the frame right here, if you look very, from here to the end from the building, that's the depth from the building. But now in front of you, it's just the surface like this. So this one you call it the picture plane. Compare 2-point and 1-point perspective is, you can say that 2-point perspective view is looking up and down from the horizontal line, result in the appearance from upward or downward from convergence of the vertical line. One point perspective is vanishing point is on a line that is perpendicular to the picture plane and intersects from the observer eyes and the standard point. It just see around us. The both 1 and 2 point perspective construction methods using orthographic view, planes, elevation, and the section. You call that orthographic views. You have example on assignment number 3 will be shown first. This will be followed by the method employed without the orthographic views that use measuring point. Now you look at this one. This one is 1 point perspective. When you look bird eyes view on the top, you can see look like this. In front of the object, you can see the height from this one is like this. And in the back side here, you look at, if you project vertical line right here, and it's like this. For the first pace is lower, and after that the second one is higher. Now if you look on this side, on the right side view, you can see that this is lower and lower right here, higher here, but the distance from here to here is right here, and this one is this one, and the high is standard one right here. This is orthographic or 1 point perspective. This is 1 point perspective. You look straight from the building and you can see the height from the building, from the crowd line and everything in front of us. Now this one more time. When you stay here, everything you can see is this face, and this is the picture plane. The building on there from that one, this means the real the objects right there. But when you stay in front of here, you just see this one, and this one can be the picture plane. Same thing with this one. This is one example, so you can draw for 1 point elevation office. For example, this one is the floor plan, and you can see the wall right here, the window right here. After that, you can see on the right side the wall, the thickness from the wall. And if you look at this one, number 1 is the picture plane, and this is the standard point number 2. So now if you look like this, you go vertical, drop down to this one, and you can see the wall right here, the thickness from the wall. The high level is the one you set up for. Same thing on this side, you have the thickness from the wall. So now if you look at this one, you look on the roof one, they divide this line. So you have this one right here, and after that they have 4 panels, and you can see 1, 2, 3, 4 panel right here. 1, 2, 3, 4 over there. That's on the top one, and after that it dropped down here to lower roof, and you can see this is lower. And after that, you can stay that point right here. You can draw. This is picture plan. You draw the ray line parallel with this one, and you can drop down to this one, so you have the thickness from the wall. And after that, you go in the corner. You see the corner from the room, and you can go draw the line, the ray line, and when they cut with the picture plan, you drop down vertical, and you see this line is the corner from the wall, the other wall, and this is the height. When you do the ray like this, you see the height from that one. And when you look at this one, the height from this one, they give you this one, so you can transfer right here and the height right there. The lower is the window, and you can drop right here with the cabinets right there. And when you draw this one to any points, and you need to draw the line, cut that point. When they cut with picture plan, you drop down, and that's the point you need to do for the roof one. The roof one, the dash one right here. So this is the window. You draw from standard point, draw the lines to the point from the window, and when they cut in the picture plan, you drop down there, so you can see this is the window. Do the same thing with the other line. You have the lights right here for the window, and the window right here, you look at this, it's the window side, so you can move this one for the true height from the window too high from the window. After that, connect with this point right there for the view. Okay, so this is the plan. Now beside of that, we have the 2 point, 1 point and 2 point. For example, this is 1 point. You look on the top view, you can see in the center, and you can see the top one like this, or you can see on this side on the left one. This is you look up and you look down, but you see one side only. For example, you stay here, you look this side only, and you do it on the other side right here or this one, and depend on you look up or look down, but just 1 point. Now 2 point is you look at 2 view. For example, you stay right here, you can see this side and this side. You can look up and you can look down, but both sides. Same thing with that, you see this side and this side. You see that this one and this one. Up or down, you see 2 of them, this side and this side. This one and this one, this one and this one. Even you look up or down, you see 2 of them, 2 views. So that's, you call that 2 point perspective. This is an example, look like I told you before, the building, and when you create that, the point from the object, it touch with the picture plane, you vertical drop down to the ground line. This is the ground line, and you got the real height from the building is right here. This is the real height, so you can go there and stop right there. If you connect this point to vanishing point left and vanishing point right, and you have the view from the object later when you draw that. Now if you stand a point right here, you draw this corner from the objects, you draw the ray line from here to there. And when they cut the picture plane, this is the picture plane, when they cut that, you drop vertical down and this one. And you see that this line is from this line from the objects. Now you see on the view, it's from here to there, AA right there, and connect to the B. So this is the side. Before you connect the view right here, so now it's inside the view. So like this. You do the same thing with this side, and you look at this, you need to draw this point and this point from this side. Okay, so basically you need to do like that on assignment number 4. So now few more definition you need to know in perspective, linear perspective. For example, this one you call that diminution. Diminution. The one right here, that means when you look close with your eyes, it's so wide, and after that it's narrow until 1 point very far from that one. Of course, the width from the bridge and everything on the light, the post, is equal. But when you look at this one, it's look like higher, and when you go very far from the point right there, it's look like smaller. But basically it's the same width and the same height from the post light. So you can see that, and they call that diminution for this one. Overlapping is one other definition. When you see many projects and depend on the standard point, and you look like the projects collapse together, but it's not, it's separate. If you look at right here and you look at the building like this, and you can see look like this one collapse on the other one, with the other one it behind of that. But basically when you look at the other angle, you can see that all of them is separate. For example, the building right here, when you look at here, it's not touched, so it's so separate. This is one project, another one, and the third one. Okay, so they call that overlapping. Another definition, they call that convergence and foreshortening. When the viewpoint right here, and you look at this, the line on the top is the line from the tangent from on of the arch. This one is the line from the base, and in the center for the line of the capital from whole of the picture you see right here. This is the line from the capital. This is the vanishing point, and this line is the tangent from the arch, and it's here is the baseline. So they call that the foreshortening, because when you look at this, it looks like they touch together. All of them look like touch on vanishing point, but the real thing is not. When you look at the foreshortening arch, it have the same height from the top arch, and after that they have the line from the capital right here. You see that? It's the same, and finally in the baseline. So basically they have the same elevation, baseline, capital, and after that the top arch. But when you look at this side, look like they touch together at the end point view. Let's look right there. Let's look like this. Okay, but it's not. And if in case like that, you call that foreshortening or conversion. Converge from the foreshortening arch to the elevation. Corner of vision. For example, you stand right here, your eye can look on the view, and usually they have dropped. You can see like this. You can look up and down like this in the angle. For example, right here you can see everything right here. Outside of that you see but not clear, so that cannot see that the corner view. So if you stand right here, standard point, the angle you can see clear in this one. So that means the corner of the view is right here. So the project is this one, the object is this one. You can see this side and this side. Something outside here you cannot see, and you cannot verify what is it. So that's it, the light. You can see the shadow right here. They call that the cone of the vision, the one you can see on the object inside there, like this one. And when you stay here, you can see the cone of the version is like this. That means you can see in the circle right here 90 degree from your eyes, go straight to 90 degree, up 90 degree, and same thing with the other side. That's the one you can see. You can see the projects, this one and this one. Outside here you cannot see. So this is perspective. When you look at here, you can see this side, and after that you can see this side. 2-point plane, like before you discussed already. And this one, the way how you connect with the other side. Before you start with the point. For example, you have the projects right here, and the point touch with the picture plane. This is the picture plane. You vertical down, drop down to the round line right here, and elevation is the one you measure from the building, so it's high right here. So the dimension right here, you call that the measuring line, and this one they show the real height from the building right here. After that, you draw 2 lines on left and the right side. From the standing point, you draw the line parallel with one side here. This is the line you need to draw for the line parallel with that one. And when that line cut to the picture plane, you drop down vertical to the round line. And this point, they cut from horizontal line is the line. Horizontal line is the line for you can your eye can look at the projects. When they cut this one, that's when you call that vanishing point right. And you combine with the point right here is the point right here. After you draw that, and you have this side. So if you start from standard point to this point, you start the construction line here, and when it cut with the picture plane at this point, you drop down. You drop down at the top right here. So this is the point you connect with the vanishing point right on the horizontal line, and you have the line right here. You do the same thing with this point. You start standard point, you start the line here, and when they cut with the picture plane, you drop down. And you connect with the point and vanishing point. So this is the line right here in this side. In the view you see like this. In front here, and you see like this one. And this side is from this side, from the other building. this side, E this side. And when you draw this one, you connect with this one, it's E this side. Center point, draw the end point, and it cut with the picture plane right here. You stop now. That's the limit from the face here to here. So it's the limit from face here to here. And the high is the real high right here. After that, you connect with vanishing point. You got this one. When you create beginning, and you have the view right here for this side. Okay, the high right here and the high right here, the high right here. That's the mark. You need to mark this one on the real vanishing point measuring line right here. You mark it right here, you mark it right there, mark it there, and compile with the viewpoint. And you got the building behind right there. Okay. So now we have more thing you need to familiar with. They call that the two-point perspective application. That the two-point cutaway section perspective when you cut for the building, and you can draw that line on vanishing point, horizontal line. The basement level show the part of perspective plane view. We also have multi-view vanishing point. Label each the block element, and after that find the vanishing point for each of them. If you have many objects, is in the different angle, and you need to have many multiple vanishing point, and you need to do each of them by the construction line. Okay, this is one example. So you can see the object right here. They have two objects, but if this one is the picture plane is right here, and you can see everything on the picture plane right here. Now if you look top view, and you see this one is this one, and after that the building right here is this one, is the top view. And when you draw that perspective, you can draw this one and this one on the paper. Okay, this is one of the call that's a multiple vanishing point, because in the object they have many different angle direction. You see this building with this building and this building is not parallel, so that's why in this case you need to do each of them. For example, on this side you need to create from center point to the line parallel with this one first, and after when they cut with the picture plane, you need to drop out to the round line and the horizontal line to make the vanishing point. But in the center, you look at the building in the center, this one not parallel with this one, so you need to create another one with this side. From center point, draw the parallel. So they call that, you can see that vanishing point 1, vanishing point right 2, vanishing point right 3. That means 3 different one, 1, 2, and 3 for this side on different vanishing point. Same thing with that. On this side, you see this line, and the line E high right here is not parallel. So that's why you need to create vanishing point left 3, vanishing point left 2, and vanishing point left 1 right here. 1, 2, and 3, and after that drop down for each of them. When they cut something on the horizontal line, and that's you call that vanishing point, and that's one you can connect with the real dimension, which one touch with the picture plane, and you got the view from that one. For example, this one you can see that in the top right here and in the bottom right here, because the real line, the dimension line is right here, the point touch with the picture plane. These two touch is the same right there, right here. So you can see this one C, the C building is right here in this side, and the other one, the B is this one. It's from here to go down here and high in back from this one. From here go straight there, and this one. A in the first of them, you can see that the part right here is the part over from B, so it's over from B right there, and on of the building is right there. Okay. Okay, so when you study the view, and you should know that's what is the bird view, what is the eye level, and the warm eyes view. For example, the bird's eye, that means from the top you look down from the building. For example, this one you look on the top bird, you look down to the building. You call that the bird's eyes. After that, eye level. Eye level is the level from you. You stand in front of the building, you look at the building, and this is you call that the eye level. And the other one, you can call that the warm eye view. That's the view you look up to the object, look down, you call that the bird, look up, you call that the worm, look exactly on your eye view when you look at, same height with your eye view. This is some examples so you can see bird view, worm view. This is the worm, this is you look at the worm. And this one you can do the bird because you look down to the objects. This example for you can see that. So when you look on the top, you look down and you call that the bird view. But when you you look up to the building, you call that the warm eye view. Okay. The read setup, that means after you draw 1 or 2 point, 1 point perspective, you can do for the read line. For example, this is inside from the theater, and you can see that on the top ceiling, you can do the read line from here, from here, from here. Far from us is small, close with us is bigger. Same thing with on the side view, and on the floor level. So if you look at the picture from the viewpoints, you can divide this one by many parts equal, and after that you connect with the viewpoint, and you can get the read line, horizontal line, round line right there. So the first one you do like that, you stay right here, standard point, and you look at the projects on 90 degrees right here. And after that, this is the both sides from the viewpoint. That's the plan view, and this is for you can do for the read line. You can divide that and you can combine with the viewpoints. So we can do that, but and they call that diagonal vanishing point method. You need to decide where your vantage point will be in order to establish the station point in the plan view, and subsequently the vanishing point in perspective. The round line and horizontal line are consequently established. You need to draw that. Draw the horizontal ground line through point 0. The horizontal line, that means the line from observer eye level. Locate in the true height distance along vertical measuring line. Before, in the picture plane, intersection point 0. Divide the measuring line at the round line where the section cut is taken into n equal increments d, and n being how many million on order interior elements must be spaced in perspective. Generated vanishing line parallel in the view from the point 1, 2, 3, 4 vanishing point. You need to create it before you start with that one. Decide on the relative depth location of element line mullions in the perspective. Select the diagonal vanishing point DVP. Locate on the horizontal line and draw a line to point 4. That's continue with that. For this is instruction for you do for diagonal line from 0 to the viewpoint. This is example from you do from diagonal line. You see the viewpoint right here. The first one you need to divide from the park in the round line. You can select the park in there. After that you connect with the viewpoint, and when you do like that, you do the same thing with on the top one from the ceiling right here. You can do exactly the same one like this. And finally you do horizontal. On the round plane, you can divide how many from the red line, and you can combine like this by horizontal line. You also can do that on the side line with the wall in the side or in the ceiling. Same way, you start from the round line, horizontal line, and vanishing point, and you connect with the ceiling. Okay, this is one example, so you can do it for vanishing point. First one, you need to divide how many on the round line. After that, you combine with vanishing point, the viewpoint, and you can connect like this. In the horizontal, you do the same thing. You need to divide how many line for this one, look like this, and after that in the vertical line also. From view plane, you can connect with that one. For example, this is the picture plane, and now the viewpoint you can combine with this one for the picture plane and this one. So everything right here is the view from that one. Few of the note you need to know is for establishing depth in the front of the picture plane. Draw the diagonal line from diagonal vanishing point through point 0 and process in the same manner. That means you do the same way when you create that one. Hand drafted read are useful for construction both on 1 and 2 point perspective. The hand drawn grid can be blown up and reduced to suitable scale, and design the sketches can be done on the trace overlays. And the preliminary design drawing, an overlay of the floor plan and the roof plan and elevation would be made on the tracing paper. You can do on the trace paper. And position plan, elevation allow adequate spaces for the perspective view when space is at the premium. Lay for the plan elevation closer together. Keep horizontal and vertical line alignment. So that's some of the notes you need to remember when you start with 2-point perspective. This is some McCoy of the vision, distortion, and perspective field. When the object is on the right side, it should be larger than 90 degrees. So you can see full both sides from perspective. But if it is smaller than 90 degrees, you cannot see whole thing from the project's vanishing point. So that's why you need to have expand the line right here. This is some other definition from perspective circle, horizontal circle, vertical circle, and after that we have the 1-point perspective with interior space. If the vanishing point is high, very little ceiling will show, but much of the floor will be shown. In the vanishing point is near the center, an equal amount of the ceiling and floor will show if it is equal. If the vanishing point is low, much of the ceiling and very little floor will be shown. This is some of the definition for 2-point perspective when you look at the projects. If you see some of the projects in different view, this is the eye level. After that, the worm eye and the bird eye. Remember the bird's eye when you look on the top, when you look down to the building. Eye level, that means similar with the standard point when you stand to look at the object in the true high. And the worm eye, that means you look from very low and you look up to the building. For example, this one is the one you look, the bird eyes, you look down. This one you look up to the building, so this is the worm eyes, that example. And depend on the angle when you start from standard point, as the projects can be different angle, and this can make the the perspective is different also. For example, this side you see the angle is different. The angle is changed from smaller to bigger, and after that the perspective, you look at the side, is different also. It can be more or less equal, or equal right here, on more or less or more, something like that. It depends on the side you the angle from the objects. You also have from the different one, it depends on if you do the angle is the same, but you change the standard points, and you can see it's different also. From the standard point, when you look straight, or you look on on the left or the right, or when you closer or far from the objects, and you can have the difference from when you draw from the perspective. It depends on you move up or down, and you can see that it's different. You see another one, can see the same angle, but you change the standard point. For example, standard point right here, right there, right here, and right there, and the side from the view is also different. This is example from the museum in French, Louis, the class outside, and museum inside here also. From the section, you have perspective view for the section also. If you not know about the section, I just remind you that section is show one part from the building. It's similar with elevation, however it has more detail about the construction inside. So when you hear about the section that you need to thinking, you can look over the construction inside from the framing, wall, technique from the wall, ceiling, window, and material inside. For example, this one, you can see the wall, and you can see the opening in there. The same thing with this one. So you can see one part from the structure of the building. Like this, you can see you see that the roof one, the deck, and after that you see the wall outside, the connection with the beam. So that's why you can see more structure. If you have section, that means you can see some structure from the building. This is the one from the rig example. You need to draw the rig before you start with the perspective. When you draw this one, you create this one, and after that you need to create on vanishing point and the rig line on the view also, for you can draw later. This one example from the people use the rig one when you draw interior design, and this one they use the rig line to draw exterior design. This is another example from they can draw the rig line because they start with the building. The rig line you need to create before you start with the wall right here, the wall right here, and the circle right there, and in the back wall right there. Another example from you can see vanishing point on the left or the right side. Some building like that, spit on the top one is not really smooth. It can be slope on the left or the right, and depend on that you need to draw for vanishing point left or right. It be slope down. If it's slope down to the depth, you can show it's on this is elevation from the depth, and you can show that's on the roof one. This is if it's sloped out to the right side, you have the technique how to draw that also. For interior one, after you learn outside, and now you can draw for the inside one. For example, you look at this one, is one corner from the room interior, and you can draw that in here. The wall right here, you draw right here, the wall right here, and after that you have one point right there for everything, for the viewpoint right there, and you combine with this one, After that, you create a vanishing point right, vanishing point left right here to combine for this one. This one is the one you see in the floor plan is this one. And after that, the door right here is this one. You can see this one, it's here. And the window on the other side is right here, and you can combine this one with this one. And this is the point. This is the corner from the vanishing. You can draw like this, and it's cut right here, and it's right there. So that's a one example. So you can see a interior for perspective. This is another one from Victoria. You can see in different angle. You can see, for example, standard point right here. You look at this one, it's like this. But if you look at the other standard point, you look at this one. Everything furniture is the same, but you change for standard point, and the view you can look at this is different also. This is another example for reflection, physics from reflection. For example, the object right here. When you stay here, you look at the projects right there, and some kind of reflection, and you can see that the angle right here, the angle right here. When you look at this one, you look up to the top. After that, you look down here, down to this one for reflection. Dimension from here to there is equal. So you can see right here, up, right here, down is equal. So reflection, angle equal, angle equal. When you look at this, and it reflect on here, on this one. So they call that the physics from reflection when you draw that. And this is some of the picture from this one. You can see that's the light right here and the reflection on there. Distance right here from distance right here equal, same thing. So that's why reflection when you draw. Another one from reflection here. This one and this one reflection, but they have the gap, surface line. So we have the gap right here. This is touch together. You didn't see the gap. Reflect surface line right here. And you see this one, they have the gap. So that's why you draw the gap right there when you do reflection. Another example from reflection. Same thing with this one. And this one is the view develop. Some of the projects, after you do everything, you need to develop more about around area, or you do something more. You ask for more people, landscape, and everything you feel that is good for your perspective, you can add it on. For example, this one, you can add the landscape and the people, or something around the building on there. For it make the drawing is more interesting, and you call that the view develop. For example, this one, you add landscape, add the vehicle, add the people. You make the building better. This is before and this is after. Add it on. Okay, so basically on chapter 6 we have many definitions you need to read. And after that, I suggest that you read a couple times for this chapter. I think this is one of the most important chapter in this course. If you learn this one, you have the strong idea before you start with to draw perspective. The curve, 1 point, 2 point perspective. After you read definition and you look at the picture, the image, for you can see that's what it is before you start with assignment number 4. This is some more definition for parallax perspective, for orthographic perspective. So you can read that and more knowledge, for you can save that in the future when you do for drawing from the from 1 point and 2 point perspective. So that's all of dimension right here. It starts for vanishing point, vertical measuring line, and they have some kind of 2-dimension surface or the angle. So that's all of the information for chapter 6. I think this one is long chapter, so that's why I give the assignment in 2 weeks for all of you can finish this on time. After chapter 6, the homework will be assignment number 4, and I allow 2 weeks for you guys can finish that. So please ace the best, because this one is very important for this class, for 2-point and 1-point perspective. Thank you for watching and see you next time.